All right, welcome to Tech Inspection, where we learn all about things around the world of drag racing. We take in-depth topics and we really dive in to see how much information there is in each specific thing, whether it's suspension, turbos, you name it, we're going to talk about it on this show. And on this week, we're talking about drag racing torque converters, and we're also going to have Joe Rivera and Marty Chance on the show. I'm joined with Brian Wagner here on the show. I'm Brian Petty. Wagner, what's going on, man?
Not much, man. Ready to do some torque converter talk and get some good information from Joe and Marty here. We've got a couple top shelf guests that are really going to give us a good education on the art of the torque converter.
Absolutely. So now I think before we get into all this in-depth torque converter, lockup, billet, all those different subjects, I want to dive right into the fun segment. And Wagner, I think I sent you 2 links to a couple of videos. This week we're going to have 2. One is kind of cringe-worthy, and the other one's just really fun to watch. So let's start with that first one that is the block. I'm not going to spoil any details. So if you just want to go ahead, I'm going to pull it up right now and watch it kind of live and just kind of talk about it while it rolls.
Oh dear.
It's bad. It's really bad.
Like, there's a lot to unpack here. I mean, safety is clearly paramount. First of all, we're using the best probably that Harbor Freight has to offer, and there's a lot of measurements being taken here in this process. It's clear that there's a lot of thought put into this what's going on here. I mean,
well, and just to be clear to everybody, this guy is obviously not doing, like, this is just for funny. This is not for anything. I'm guessing it's a 305 small block Chevy, so it's, I mean, other than a giant paperweight or a boat anchor, it's not really good for anything, but I just thought it was funny.
We're reaching for something from the Home Depot with clearly no regard for water jacket holes or anything like that.
Oh,
we're just, it's like he's putting in a bathtub.
And I love how uneven the grinding is. He's just going over it everywhere, digging giant holes. I thought it was funny. It makes you cringe a little bit because he's just ruining a block, but at the same time, it's a boat anchor. So,
well, here's what makes it more cringeworthy is you can laugh at that video all you want, but there's a distinct possibility that someone has done that being dead serious.
Oh, absolutely. Like, you're thrashing, you don't know what you're doing. Your engine has a problem, it's leaking coolant. Oh, let's just pull the heads off and grind it, clean the surface with a grinder, and silicone it up. Why not? It's fine.
It's like watching like one of the Saw movies. That's terrible.
Yeah. Okay, so let's move on to the next video for the fun segment, because this one I found, and I've watched it probably 5 or 6 times, and I continue to keep watching it because basically this is to give you a little bit of information, this is the stock bottom end 4.8 liter LS based engine record. I think it goes 7s in the quarter mile, 791, and I'm clicking it right now to open it up because it is something that is just insanely cool to watch, especially with the data overlay. I love it.
Yeah, the data overlay is really cool because, you just kind of watch it going down the track, and, I'm looking at the timing and the AFRs. And that right there tells me exactly why that little block and that little engine is living as long as it could, because it's right where it needs to be for any power level, let alone what they're trying to do with that engine.
Absolutely. It's funny to watch. I really like watching how boost comes in, showing the timing slowly dropping, intake air temps going up over the run. I'm watching it again. Watching fuel pressure.
Well, look at the other thing a lot of people don't pay attention to is that injector duty cycle, because you got to make sure you keep that in that sweet spot, because the second you push it beyond, different tuners have different numbers on what they suggest, but you don't want that to hit 100%, because that's when real bad stuff is going to start to happen in a hurry.
Absolutely. It's funny because oil pressure, generally you see it drop quite a bit, and so I'm wondering what they've done with the oil pump, because at the end of the run they're still, high 70s, low 80s, and that's not something you typically find in a stock bottom end LS. Usually at the top of the track they're tanked in oil pressure, and so I don't know, a lot of questions, really fun to watch, to watch the car, watch the data, watch the wideband, and they have all these different parameters, super cool. But I thought it was worthy of putting on here for sure. So now that we have done the fun segment, we've seen a couple fun little videos. Now we're going to work right into our guests.
Yeah, and kind of priming the pump on what we're going to talk with them about. Torque converters are almost a black art to some people because it's just this weird circular device that does crazy things, and a lot of people, they're afraid of them, and they think that there's all these moving parts. There's only like 4 or 5 parts inside that thing. So I really want to cover with these guys, how a torque converter works in a dedicated race car, some of the trends that they're seeing in torque converter technology, because there's some really, really wild stuff that people are doing up there. Talk about lockups versus non-lockups, because you hear that thrown around a lot and people might not know. And then kind of, hit them up on looking at, your stock welded, I say stock, your typical weld together style converter versus a bolt together converter, and kind of some of the differences there. I think that's some stuff that the people are going to want to know about.
Absolutely. And just understanding where converters were 10 years ago and where they're going to be in the next 3 or 4 is something that I really want to talk about with them for sure. But I think you've covered quite a bit of the different things. So let's just go ahead and get Joe. So we have Joe Rivera on the phone. So Joe, thank you so much for coming onto the show. We really appreciate having you here. And I just want to get right into this and get your feedback on torque converters, your experience with them, and what you've seen torque converters, come from 5 years ago all the way till now, and then possibly like what they're going to do, here in the future.
Well, happy to be here. Thanks for the invite. Greatly appreciate it. I know enough about torque converters to be dangerous. What do I know really? I know a few things. Not a whole lot, but enough. So what do you want to know, guys? What's the first questions that come to your mind?
So let's just start off with more basic stuff. The difference between, like, say, a fabricated converter versus a billet converter, when you would, choose one over the other, why there are 2 different styles of converters, there's bolt-togethers. Let's talk about that.
Okay, so there's a lot that goes into it, and there's no quick, simple answer for any of it. And really understanding the vehicle combination is really what you need to pick a converter. I mean, there are a lot of good, high-quality, well-informed torque converter guys out there. I want to promote what we do with ProTorque as a brand, but the reality is there's a lot of good guys out there, and technology has ramped up. You said 5 years. Well, we came on the scene. I mean, we've been doing performance. I've been doing torque converters since I'm literally this big, right? Worked in a shop. I was 12 years old. Worked full-time summers and weekends from the time I was 12 on, right? So I've got a lot of experience in the OE side, and then we've been doing performance work since the 90s. And there is no quick, what fits what. It's about understanding the vehicle combination. So 10 years ago, we started with the turbo stuff and the Revolution series, and that's kind of where we became known for in the genre of drag racing and drag zine, followers. We became known well for the turbo stuff. So to answer some of the questions, what's the difference between a fabricated and a billet? There's a lot of bullshit out there, guys. Like, what is billet? I mean, billet is bullshit in most cases. I can use it for you. Is a forging a billet? Well, it depends on who you speak to. Is it, what do you consider fabricated? It's all fabricated because you're making it. So let's. And then the next question was bolt togethers. Why a bolt together versus a weld together? I mean, some of the fastest cars in the world are still weld together torque converters. You don't need a bolt together to necessarily have the fastest and the best stuff. Now, there's a lot of advantages to the bolt together. You can service it. You can adjust it. If the trans fails or there's contamination, you can crack it open yourself, or you can save the shipping. Or if you want to make an adjustment, no problem. You can unbolt your torque converter, take it apart, clean it up, change your stator, put it back together, and away you go. So there's no one quick answer. Some guys would be like, you can sell me a bolt together, but I'm never going to take it apart. I'm going to send it to you. All right, cool. There's still some advantages to having the bolt together. It's easier for us to take apart.
Well,
so
kind of going off of that, Joe, when drag racing, as you mentioned, trying to figure out the combo and whatnot, matching the converter to that. Part of that, the magic inside that converter is the stator. How should racers try to, to explain that to the racer? What is that magical stator in there? How does that function? What does it do?
All right. So the stator is really it would be the equivalent of the cam. It's what tells the engine what it's going to do, where it's going to do it. It's the equivalent of a valve body. It's going to be the brain of the torque converter. And the stator assembly is basically the part that redirects the oil inside the torque converter. It's charged with torque multiplication. It's charged with coupling, the coupling efficiency, and the curve in which it's going to apply. The stator is basically, if you're a clutch guy, is the counter and the base. It tells you, how much counter, how much base it is. It tells you what RPM it's going to be. It tells you what recovery it's going to be. It tells you how it's going to multiply the torque. The torque converter multiplies torque. So it's really the magic. We started doing billet stators, I think almost 11 or 12 years ago, and really nobody was doing it back then. And that's really I was looking for consistency. I was looking for controllability. When you hand build a steel stator, there's always going to be some variances. It's hard to replicate. So we went to the billet stator a number of years ago, and it's really made a big difference because we can be very, very, very consistent, and we can control how the torque converter is going to operate and transfer power based off of that billet stator design. Not unlike, you'd have to look at the stator almost to like a turbine housing or a turbine wheel. The blade, the angle, the count, the curve, all of those are going to determine how that turbo is going to operate or spool, or how quickly it's going to build boost and how much volume of air is going to go through.
So now I want to get your feedback on the differences between like a lockup and a non-lockup torque converter, because that's something that we've been seeing a lot more and more, and just want to know the differences, and then also why now? Like, why are lockup converters becoming so important and so many people are running them?
Yeah, I mean, again, you can kind of split hairs on that. There are plenty of cars that have gone extremely fast non-lockup, and they may be within a number of two, right? Lockup to non-lockup, or maybe it's three numbers, depends. But if you can't get the power to the ground, I don't care if it's locked up or not. The bottom line is how much power do you have and how much can you apply. I think the lockup thing, it's not anything new by any stretch of any imagination. I mean, the lockup torque converter in racing is 25 years old. I mean, it was being done by Trans Specialties and a company up in Canada, Vic. I can't remember Vic's name. I think it was, I can't remember the name of the company either. But it was done in Canada a long time ago. So what's the purpose of a lockup? There's a speed ratio in a torque converter. Engine RPM is connected to the torque converter itself. Drive shaft is connected to the input shaft, which is the turbine. So there's always a certain amount of slip between the two. In a traditional open style torque converter, what you have is the engine RPM the torque converter is connected to the engine RPM, and you've got a turbine connected to the drive shaft or the input shaft, which drives the drive shaft. And there's always a certain amount of slip or speed ratio. Traditionally, in high horsepower cars, it wasn't great. If you go back 10, 15 years ago, if you get to single digits, you were ecstatic. 9, 10, 11, 12, 15%. I remember, turbo cars were 15, 20%. You're like, oh, I'm losing all that power. It's a lot. Everybody's kind of come up to speed. We can typically see mid to high single-digit efficiency numbers in eighth mile, and mid to low single-digit efficiency numbers in quarter-mile cars. 2, 3, 4% with a car that's properly geared is commonplace. That's what it should be if you get it right. In the eighth mile, 4, 5, 6, 7, 8% if it's geared right. So there's that percentage of loss, and it's important. So why did they go to a lockup? They wanted a 1-to-1. So you have engine RPM is your drive shaft RPM. Now, there's some upsides and some downsides. It's not for your faint-hearted. First of all, it's not inexpensive, right? So the price point, I don't care who you get it from. You're talking about a whole new level of complexity there. You're adding lockup clutch, you're adding pistons, you're adding an inch space. There's a lot of complexity to it. So the parts are considerably more expensive. The transmission's more expensive. You got to space everything out. Then there's the management of the power. Look, if you're at a point where you can't make any more power, you can't apply any power, then a lockup is the next step. And that's where you look at like some of these RVW cars and some of these pro mods, like, hey, they're throwing everything at it and they want to squeak out the last bit of power. Well, then that's how you do it. But lockups in traditional street cars, I mean, Chrysler's had them in the 70s. There were domestic manufacturers in the 50s and 60s that had lockups, right? But it became prevalent in the 80s, mid 80s, when street cars had lockups. The overdrive transmissions in Chryslers and in GM front wheel drive and 200. People remember 204Rs and 700R4s. Turned into the 4L60, 4L80, 6L80, now the 10L80. So it's just progressed. They want no loss between the engine RPM and the driveshaft RPM, and there's a clutch assembly that locks up against the back cover, so you have a 1-to-1. So there's a clutch that applies to a cover, and you have a 1-to-1. That's the lockup.
So, we're getting ready to wrap things up here, Joe. What do you see as the future trends here quickly with torque converters? You look into your magical torque converter prediction box. What do you see you guys, coming up with? What's the next big thing?
I think, I hate to say this, the reality is, although I don't promote it, I think given the current set of circumstances with this COVID-19 stuff that we've got going on, drag racing is really kind of on hold. We have to be honest. Let's not lie to each other. Nobody's gone racing in the last 6 weeks. Okay, they closed, they canceled Gainesville, and we haven't raced since. So when are we going back racing? And then when we go back racing, are we going to have big crowds? Are people going to be ready to maintain social distancing? So I hate to tell you, there's going to be a lot of street racing. I see it now. I see it already. The guys who are itching to get back are the guys who are street racing. They're like, hey, I got to race. And I'm like, wait a second, there's no racetracks open. So if I have to predict what the future of the sport looks like right this second, on the short term, I think we're seeing a lot of street racing. And those guys do require something different than what we would with a pro mod or an RVW car, where you walk across the track and your sneaker stick, right? It's not about how much power can we put down. It's how much power can we get across this surface. And in that case, looser is better. So we've got a lot. So you got a lot of guys making changes because they're like, well, I got nowhere to race, so I might as well pick up a local grudge race. And how long? Hey guys, how long before we go back to racing? That's what I want to know. What do you guys think?
It depends on who you talk to. I think we'll be back to the track probably like large scale stuff May, June. That's what I think it's going to be.
I think that's a pipe dream, my friend.
Don't ruin my day. Don't ruin my day.
Look, you asked me what the future is, right? That's my opinion. Listen, I want to go racing as quickly as possible, but the reality is, the truth of the matter is, it may be longer than that, and we have to be prepared for it. So how does that relate to torque converter technology? I think a lot of no-prep racing is going to be looser up front, so you can get it down a trickier track. That's all about understanding how they operate. I know one of the things you guys had mentioned was, how do you determine what the car or the vehicle needs, and really through data acquisition. You had mentioned a question about, how do you do what you do? It's really data acquisition, race pack, fuel tech, Holly, Haltech. I don't care what system you use. You've got to look at what the engine RPM is doing, what the drive shaft is doing, what the G meter is doing, and that's going to determine how you're going to apply power. I know it sounds counterintuitive. A lot of times guys say, I can't get down the track, or I can't get down the street. Well, sometimes you got to put more power at it than pull power away. You got to get ahead of that curve. You got to kind of get ahead of the converter and loosen it up with power. So it's about power management.
Joe, I hate to cut you off. We are completely out of time. Definitely we're going to look at bringing you back and start talking about some street car stuff, some street racing. You got some ideas, definitely a lot of experience. So thank you again so much for being on the show, man. We can't tell you how much we appreciate it, but definitely have you back on, and we'll dive more in depth on some street car stuff. Like I said, again, we appreciate having you on for sure.
Yeah, happy to be here. Thank you so much.
Okay.
If you're home and you're bored out of your socks, I was locked down a couple of weeks ago by my my lovely bride, and apparently the governor is all too. So we're doing what we can to do to get product out. Unfortunately, we're kind of limited. A lot of companies are in the same position, but anytime we'd be more than happy to come back on. I look forward to getting back to racing as quick as possible, and thank you for having us on.
Yeah, thanks, Joe.
We got Marty here on the line with us, Marty Chance from Neal Chance Racing Converters, who I've talked with many times writing articles and has a crazy depth of knowledge about torque converters. So it's awesome to have him on the show. Marty, thanks for joining us.
Yeah, right on. Thanks for having me, guys.
We've had a lot of different conversations, and torque converters can scare people really quick because they can seem kind of crazy and complex. When you how do you explain, how a torque converter should work in a dedicated drag car to your average racer?
Sure. Well, one, I want to say that you're 100% right. The more a guy understands about the torque converter, the less scared he's going to be of the magic black box. In simplest terms, a torque converter, to describe how a torque converter works or what it is, put it in simplest terms. A torque converter is a hydraulic power transfer. That simply means power from the crankshaft is going to be transferred to the rear tires through a hydraulic or a liquid power transfer. Okay? So how does a hydraulic power transfer work? Visualize two kitchen fans sitting in front of each other. And if you turned one of them on, it's going to spin the other one, right? Okay, so the one that's turned on, that's the driving impeller. The one that's not turned on, but it's spinning because the other one's blowing into it, that's the receiving impeller. All right, your pump side on your torque converter is the driving impeller. It's hooked to the crankshaft and is turning direct one-to-one with the crank. The receiving impeller is the turbine. That's hooked to your input shaft, and that's hooked directly to your rear tires, right, through the driveline. So when the crankshaft, the pump side, spins enough fluid into the turbine, the receiving impeller, to turn the turbine, it turns the rear tires. Okay, that's a simple hydraulic power transfer. Now, that's called a fluid coupling. But a torque converter is different from a fluid coupling because there's an object in between those two sets of impellers, that pump impeller and that turbine impeller. And that's your sprag and stator. You see, originally the first automatic transmissions had a fluid coupling, not a torque converter. But the problem with the fluid coupling was it coupled at too low of RPM for a hydraulic, for an internal combustion engine, a gasoline engine, to pull the vehicle. They tried to lock up at like 600 RPM. Well, motors back then didn't make enough power to pull them, so they needed to create some slippage. So that's where the torque converter replaced just a simple fluid coupling. And you put a sprag and stator between the two sets of impellers, the pump impeller and the turbine, and now your fluid coupling becomes a torque converter because the sprag and stator locks one direction, which creates a stall mode. That got rid of their problem of it locking too low RPM because you create some slippage, bring the engine RPM up, and now the motor's got enough power to pull the vehicle. So in simplest terms, that's how a torque converter works. You got a receiving impeller, a driven impeller, and then you've got the sprag and stator between the two to create a stall mode and an efficiency mode. Stall mode is when the stator is locked, and then when the stator unlocks and tries to spin with the pump and impeller, that's your efficiency mode.
So now that we've covered the basics of, how a converter works in layman's terms, let's jump into, your expertise in talking about what are the main differences between, say, like a stock / fabricated torque converter and like a more drag race oriented torque converter, because there's a lot of OE cars that have torque converters that stall to 1600 RPMs and they're made for driving, and then you got drag race converters that don't have any lockup of any kind a lot, or sometimes they have lockup. Talk to me about the differences between like a normal torque converter and a full-on drag racing torque converter, and what you guys have seen and what you guys have changed over the years.
Well, sure. A stock OEM converter is made for the power range of a stock OEM power plant. And they typically can be loaded at much lower RPM. But you take your racing motor and you put a 800, 900 lift cam in it with a lot more overlap. Well, it lost lots of low RPM power. It doesn't have the power at 1800 RPM as a stock vehicle does. It may make peak torque at 6500 RPM and peak horsepower at 7800 RPM or something like that, right? So now we've got to move that. Now that the power curve has moved up higher in the RPM range, we've got to make the converter not load the motor until that RPM range. So you've got to increase the slippage or the stall, which, by the way, slippage and stall pretty much mean the same thing. The word stall is a marketable word so that you're happy with slippage. You'd love to have a 6,000 stall converter, but you wouldn't want a 6,000 slippage converter, and yet they mean the same thing.
It's a very, very good point with the usage of kind of terms there. One of the things that kind of going off of that, when you have these different converters, is you have lockup and non-lockup converters that you hear get talked about now, whether they can be used in different rule packages and whatnot. What's the difference between, if someone's going out to look at these converters, what's the difference between a lockup and a non-lockup converter?
Okay, lockup versus non-lockup. Well, back to our basic description of a converter being a hydraulic power transfer. That's a non-lockup converter. A hydraulic power transfer is simply putting power from the crankshaft to the rear tires through a liquid power transfer. But a lockup converter has a mechanism inside where you're basically locking the input shaft to the crankshaft. And when you do lock it, you're bypassing the hydraulic power transfer and you're locking it solid. Now you're a solid power transfer, not a liquid power transfer. So you lock the converter through a mechanism like a set of clutches that lock the input shaft to the drive cover. And of course, the drive cover is bolted to the crankshaft. So in essence, you are locking the input shaft to the crankshaft. And it's usually through a clutch, like a clutch disc or multiple clutch discs that are applied hydraulically. And that'll just lock the input shaft to the crankshaft, and you're one-to-one. There's no slippage. You see, a hydraulic power transfer, a simple regular converter, non-lockup, will never be one-to-one. Now, there's ways to fool your race pack. You used to have guys build spragless converters, and that was really kind of something that took advantage of the consumer who didn't know any better. But a spragless converter sometimes will give you fool's gold on the race pack. It will show you the dry shaft catching the engine RPM, and it looks like you're almost one-to-one or one-to-one or really close to it. But if you look at your G meter, your G meter's tanking at a faster rate than it should, which gives you the first clue that spragless was giving you fool's gold. It made you think that engine RPM to dry shaft RPM ratio was better than what it really is. And the evidence is the G meter. When the G meter's falling out and the vehicle's not accelerating, but you're seeing a slippage number between dry shaft and engine RPM that looks really good, thinking you got what you wanted, that's fool's gold. And again, the G meter is your evidence. And what's actually happening is the spragless will become a water brake to the motor. It literally stops the motor. You can see a spragless on a race pack real easy. When the thing shifts to high gear, the engine RPM will drop like normal, but when it goes to recover, it'll hit a certain RPM and almost flatline that RPM all the way to the finish line. That's a telltale of a spragless, and unfortunately, that's not what you want. Now, when you lock a converter through a lockup clutch in the torque converter, and you get a true 1-to-1, now you're getting a greater power transfer, and you'll see that in the G meter. So now that I've kind of opened Pandora's box, I started talking about power transfer. I'm going to tell you a secret about tuning, and that is engine RPM to dry shaft RPM is an important thing, but it doesn't tell the whole story. It can be misleading. Again, when you're tuning the torque converter, you're tuning for the maximum amount of power transfer. And so your G meter and your drive shaft will be your guide, not your engine RPM to dry shaft ratio. Those are still important. That's good information, but that's not the end all. That doesn't tell the whole story.
So, Marty, now that we've gotten a pretty good download on some other subjects, I want to hear your opinion and your feedback, obviously, because you know way more than pretty much anybody else about torque converters. Let's talk about how they've progressed over the years in drag racing. I mean, in the last 5 years, they've made leaps and bounds, and like, are we to the end of that, or do you see something else coming in like the next 3 to 5 years? Talk to me about that progression.
Oh no, the future's so bright. We're gonna have to wear shades. Take that from an old song, huh? No, what's coming down the pike? I'm so excited about. I don't even. I got to be careful what all I say, because some of it I don't have patents on, and most of the world, most of the high-end racing world knows us as the technology company. Ain't no way to say this without it sound like bragging, but 90% of the technology over the last 30 years in racing torque converters have been Neal Chance racing converters. You know, we brought the bolt together converter to the racing industry 35 years ago, and it took the rest of the industry 20 years to copy it. We brought all the billets. We had the first billet drive cover, the first billet stator. We was doing billet stators in the 1990s. We built the world's first all billet converter. We built the world's first NXS converter, that split blade impeller, designed specifically for load sensitive motors like the blown alcohol car. I mean, that thing was the nail in the coffin for the clutch car to try to compete against a torque converter car in the 8th mile. When we invented the NXS, the 10-strut mechanical diode, we invented that. I mean, we are a technology company. We have in-house engineering. We have in-house CNC machine shop. We even have aerospace companies come to us. So we have a subcontract division where we do like 5-axis programming for aerospace companies like Boeing. When the supercar world, like Koenigsegg, wanted to develop the world's first supercar with a torque converter, they came to us. What we have coming down the pike for torque converter technology, it's amazing. We keep finding better ways to transfer more power to the rear tire. Now we're kind of getting to the point where we're going to defy what your grandfather told you. He said, "Son, there's nothing in life for free." Well, that's pretty much true 99.9% of the time. But we're coming up with some stuff that utilizes torque multiplication to a greater degree. And torque multiplication is the one time in life where you get something for nothing. You can literally get more power out of the converter than what went into it. And we're developing ways to get all of that, get every bit of it there that is capable, and be more efficient with how much power we're able to put to the rear tires. We're also getting around some rules. You know, everybody knows, 8-9 years ago, NHRA banned my lockup converters. Well, politics is what it is, and NHRA is the world's greatest at Chicago politics. And that is Neal Chance, you don't get a play if you don't pay. And they banned my lockup converter. Had a conversation with the rules makers like 9 years ago when they first banned us, and they basically told me that the difference between a lockup converter. See, I had this conflict when I said, listen, the clutch is legal, the torque converter is legal. You get to lock the clutch up, but you don't get to lock the converter up. And they corrected me and said, "Oh no, we do not allow lockup converters." I said, "But guys, that's a play on words. They both lock up." They said, "But the difference is a lockup converter has an external force that tells it how and when to lock up. Where a lockup clutch, they were saying a lockup clutch. A lockup, a regular clutch has only centrifugal force to make it lock up. It locks up on its own natural centrifugal force. So we actually have all the patents. We developed the converter. We call it the limited slip converter, and it works 100% the way NHRA said. There's no external force. It is able to lock up only on its own natural centrifugal force and applies that with manual weights that you change just like you'd change on a regular clutch. This is just a regular converter. This fits on just a regular transmission like a Powerglide, a Turbo 400, a Bruno, a Lincoln, any regular non-lockup transmission that you already have. This fits right in it. It's same height as a stock GM converter, and that is going to be one of the biggest game changers since the bolt-together torque converter. That's going to allow the smaller, the smaller budget racers to compete against the big budget racers who can afford the lockup converter and lockup clutch, lockup transmission and lockup converter together, which a lockup trans and converter together is about $25,000. This is going to be very, very affordable because all you got to do is put the converter in and adjust it yourself. That's one of the things that's coming down the pike. But there's so much stuff for torque converters that to look into the future, even in the next 12 months, it's going to change significantly. So what do I think the future looks like? I think the future of torque converters is so bright you got to wear shades.
My number one favorite thing coming out of this and to take away is the fact that torque converters have been around for a long time. There's a lot of technology, a lot of advancements, but the fact that the future is so bright is my favorite thing that I heard from Marty for sure. But Wagner, what about you?
Yeah, just the thought of what these guys coming up with, that's my big takeaway. With what Marty was talking about with the those crazy tunable converters, and kind of Joe breaking down that it's important to make sure you have your combo and what goes into to making sure you have a proper converter, an efficient converter. That's really good stuff there. But like I said, there's so much knowledge there between those two. We could do hour-long shows with each one of them, no problem.
Absolutely. The future for torque converters is very bright. The future of the automotive industry is insanely bright. And thanks again to all the listeners and viewers. We really appreciate everything that you guys do. Make sure to give us feedback. Let us know what you think, ideas for future upcoming episodes. And stay tuned right here for all of our other shows, and we'll see you in the next one.